Good morning, everyone. Thank you for having me. This is it's astonishing seeing how many eggs there are now. They've been multiplying over the years. Yeah. Hello, everyone. My name is Armando Casillas. Graduated from EG in 2019 with a master's under the science and technology I guess track, two different tracks, right? Yeah, I started working at Lawrence Berkeley National Laboratory in 2019 as a scientific engineering associate. I work in the division called the Building Technologies and Urban Systems Division. So in more specific terms, I am what they call sort of like a building scientist slash engineer. And the majority of the work I do focuses on the mechanical and the digital systems that exist in our buildings, both commercial, residential, and sometimes in industrial buildings. The work I do can be divided into two different bins, some low TRL, technology readiness level, and high TRL, more industry facing work. First I have a lot of time spent in the more R&D focused topics. The lab is primarily funded by the Department of Energy. The Department of Energy has made moves in recent years to more clearly articulate and define the need for what they call grid-interactive efficient buildings, or GEB for short. And GEB has been sort of in like the term that we use now more commonly to refer to these types of buildings that can receive and send signals to the grid, can respond to changing dynamics of different renewable energy supply, and just are more intelligent in that way. The whole GEB initiative was honestly great for me because I came into UC Davis really interested in these topics. I started off in UC Merced as an energy analyst under the facilities management team. Basically looking at buildings on campus, you would get calls, people saying, it's really hot in my room or really cold in my room. And I would jump on like the building automation system where you can see all like the bells and whistles, everything moving and all these sensors. And we'd have to determine what's wrong with the building, troubleshoot the building, and then relay that information to an HVAC technician that would go in and fix what's going on in any particular building. So, that sort of stuff also tied into some of the renewable energy planning happening on campus at UC Merced. And that all got me really interested in how buildings can interact and even enable the transition to renewable energy. A lot of the sort of mini projects I did at UC Davis for different projects over different classes involved demand response or demand flexibility, how buildings can respond to the needs of the grid via price signals or just event signals. And I sort of carried that interest throughout my time at UC Davis. What we have traditionally called demand response, I sort of used two different terms there. Demand response is was basically traditionally used as a form of peak load management. So you could think of like your flex alert days, in the middle of the summer. There's a lot of air conditioning load. We all get texts or emails saying, please don't use your electricity between these times because of the high strain on the grid. Some people in UC Davis, in Davis area, or more engaged folks use Ohm Connect, and Ohm Connect sends out their Ohm hours and says, please don't use here. And it's basically a form of traditional demand response to sort of try to shed load during high peak times. Now we call this demand flexibility in the research world, which instead shifts the focus to more to demand side management capacity as a function of time of day, weather conditions, and in sort of my area, building characteristics. That includes the HVAC system, the control strategies, the envelope, windows, occupancy patterns, all of that. All of that is a sort of input to the flexibility that a building can provide at any given time of day or time of year. So one of the projects I'm currently working on involves developing standardized metrics for demand flexibility. How can we quantify this for both shift strategies, so moving energy to sort of lower use time of days, and shed strategies, trying to shed load during these peak times. Mainly, like I said, I focus on how the HVAC systems can provide this demand flexibility, which in addition to predominantly being the highest load in commercial and some residential buildings, are one of the only systems in a building, if you think about it, that move, right? Like that not a lot of things in a building actively move and can be stopped or sped up or slowed down. So that's why a lot of the focus does go into the heating, ventilation, and air conditioning systems. This involves a lot of controls programming and knowledge, which I'm getting progressively better at. Like I had some foundation from, like I said, UC Merced and also UC Davis's, my time at UC Davis with Western Cooling Efficiency Center, as well as some of the coursework I took during my my master's program. As I've mentioned, I did work for the Western Cooling Efficiency Center under Mark Madera. He was my master's PI. I worked on a project, I think it says in my bio, looking at wireless networking systems, wireless networked sensors and how they can help with building leak detection. So that did get me sort of more into how sensors can provide more meaningful data for energy efficiency measures. Some of that experience there has helped me contribute to the work in our state-of-the-art experimental facility called FlexLab. So FlexLab is sort of the crown jewel of my division, Building Technologies and Urban Systems division, as I mentioned. It's a highly flexible facility that includes customizable spaces and HVAC systems to test out a large number of different combinations of different, configurations of buildings. So an office building with an air handler, or an office building with an RTU with multiple zones or one zone. You could do all kinds of different permutations of different systems to try and carry out some of these building flexibility strategies and experiments. So that's sort of the first half of my work. And then the second half of my work is, like I said, higher TRL, more focused on industry-facing initiatives from DOE, focused on more smart building technologies that are already developed, including automated fault detection and diagnostics and smart building platforms. So automated fault detection and diagnostic systems, you could sort of think of, the check engine light in your car, right? It just kind of tells you that something's wrong. Some smarter cars take you a step further and tell you what's going on. Maybe you have low tire pressure, or you need to change your oil or whatever, right? That's a common form of automated fault detection and diagnostics. And this is becoming increasingly prevalent in commercial buildings, especially highly automated commercial buildings with a lot of data availability and sensors. And it's used as an energy efficiency measure in these buildings. So I work on top of that, I also work on one of DOE's technology validation programs, namely the High Impact Technologies Program, which aims to get technologies that have been identified as high impact. So, technologies that can provide a lot of energy efficiency or have other non-energy benefits into buildings to evaluate their value, their cost effectiveness, things of that nature. So LBNL leads the evaluation as an objective party. So, we kind of stand back, we're sort of the referee and seeing how, these vendors interact with building owners. And we focus on applying industry specified measurement and verification guidelines. So, how can we take a baseline? How can we create a baseline and then overlay the post-installation performance of the building on top of that to identify the savings provided by the technologies? I have one project right now in building in Washington, DC, and another project in Illinois that's currently kicking off. A lot of these measurement and verification projects have suffered a lot the past year and a half due to COVID, since it's really hard to determine how much energy savings a technology can provide when all of a sudden the technology is installed and then everyone leaves the building, right? So that's really hard to determine how much of those savings are attributed to the technology. So this has left us to resort to whole building energy modeling of the energy conservation measures that are executed by the technologies to then evaluate the savings. So this is, not a conventional way, but it's still one of the accepted ways of developing savings calculations for these technologies. I mentioned whole building energy modeling. A lot of the work I do does involve modeling of different systems, whether it be the whole building energy level or particular HVAC systems with different control systems as well. And programs such as Energy Plus or languages such as Modelica, which is primarily used by the automotive industry. So there is some modeling involved in the work that I do, and it sort of permeates across all of the different projects that I do in some way or form. Do a lot of data analysis in Python and different controls programming. So like that's anyway, that's kind of like the overview of like what I've been doing the past couple years at LBNL. It's quite a lot and can be overwhelming at times, but it's also very fun. And yeah, anyway, that's my overview. Thanks.
Thanks so much, Armando. I think maybe what we'll do is we'll go to the next person, and at the end we'll take questions. Although if anyone has very pressing questions about some details, I think feel free to raise your hand and we can have Armando field them. Otherwise, we'll wait till the end when we'll have sort of a panel for everyone. Give you guys a minute. Okay, well, with that, I'll pass the virtual microphone to Madison. Madison, please go ahead.
Thank you. Hi, everyone. Nice to see a lot of new faces. I recognize like a total of 5 people, which is pretty cool to see how much growth there has been. And I just want to say thank you to Alyssa for inviting me back to be a part of this panel. And it's an honor to be able to connect with some of the fellow AG students. And I do want to mention that I really do enjoy connecting and reconnecting with AG students. I try to join you guys with some of the things that you do. I participated in the last AG camping retreat and some of the other fun events. And so that's all to say that I hope to meet you guys in person at some point, especially since I do live somewhat nearby and go back to Davis every so often, since I'm in the Bay Area. So just wanted to preface with that. And I might go about things a little differently than Armando. I was going to share a bit of the trajectory of how I decided to apply to the AG program. So I'm going back a little bit further, and also how I decided to end up working at PG&E. And I figure I can give that high level overview, and anyone can ask specific questions about sort of my career path or any particular experiences when it does open up to Q&A. And I do want to say that I'm available anytime after this seminar for specific questions as well, or just to have a conversation. So I do hope you guys feel comfortable reaching out to me by email or inviting me on LinkedIn or any other way to communicate with me. So going back just to start with, at least at college, I'd say that's where I became very motivated about the environmental science and policy field. And at that time, I have to say I was interested, honestly, at kind of in every aspect of the environmental field. And it was definitely an awakening and overwhelming time for me, trying to figure out what to focus my time on during undergrad. And I had a lot of those similar feelings when I was in grad school as well. You're exposed to a lot of new information, and there's so many opportunities. And so for those first couple of years of school during undergrad, I ended up spending a lot of time in the field and working in a lab doing some soil sampling and working with 2 ecology professors at my university, which was Chapman University down in Southern California. And at that time, I honestly was most excited about just spending a lot of time in the field and getting my hands literally dirty in soil and just trying to understand what research was, since that was honestly my first exposure to being a part of a research project. And plus I'll add that I also very much enjoyed spending time with the 2 professors that I was working with, which was a huge motivation for wanting to spend a lot of time in their lab. And then it was about halfway through college when I took a bit of a pivot after taking this geographic information systems course. And that was my junior year. And I was introduced to a whole set of new types of research questions that involved spatial analysis and mapping. And I became very intrigued with geography and being able to use maps and spatial data to be able to ask different types of questions and answer different types of research questions than I had before. And I also very much enjoyed using this ArcGIS tool that I was introduced to at the time. And so I decided to take advantage of the summer between my junior and senior year and wanted to test out actually using this new tool that I had learned in the classroom and actually trying to apply it to a real research project. And so I had reached out to some PhD students and postdocs who were working at a university near my parents, since that's where I was going to be during the summer, and just reached out to see if anyone wanted support during those summer months with their research and allowing me to help out with kind of the GIS portion of their research. And so I came across a really interesting project about utility scale solar energy and understanding the impacts of these very large scale systems that they have on our ecosystems and land use, and trying to mitigate those impacts. And at that time, I really didn't know anything about energy, but I was definitely very curious to learn a lot more, since there really weren't classes at Chapman that focused on energy systems or really any topics that were about energy specifically. And also, the other kind of attraction to that work, that research project, is that the PhD student, Rebecca Hernandez, who was leading that research, seemed like a really nice person to work with. And you could tell that mentorship was a very high priority for her, which just made me feel like I would be, felt more valued and motivated to actually want to work with her. And so I worked with her over that summer, as well as a little bit during my senior year. And this research actually ended up leading to my first job after college. And Rebecca was able to hire me on as a junior research specialist. And I was able to continue working with her for what ended up being several years more. And the research took me from Stanford University, which is where Rebecca was during her PhD, to then UC Berkeley, which is where she got a postdoc position, and then UC Davis, which is where she got her faculty position. And it was my experience at UC Berkeley that I'd say really got me interested in thinking about graduate school. And when I was there, I was exposed to this really cool graduate program, the Energy Resources Group, ERG, which I'm sure some of you have heard about. And that program had students working on so many interesting environmental and energy related research topics that were they were really eye-opening to me and very inspiring. And I was also surrounded just by incredibly smart and just genuinely down to earth great people who were all passionate about climate, just like I was. And that experience just really stuck with me and got me interested in wanting to go to grad school. And so when I was in Davis looking into grad programs, Ben Finkler had reached out to me and put it on my radar that Davis was starting an energy focused graduate program that would have quite a lot of resemblance or qualities to the ERG program. And so the more I looked into it and thought about it, it really did seem like a kind of too good to be true kind of coincidence that it popped up at that time, especially given my potential research interests at that time, which were based around the food, energy, water nexus. And honestly, Davis is an ideal place to study all three of those areas. So my first year in graduate school, I ended up, I was dabbling in some different research topics to try to figure out what my thesis should be on, which I'm sure many of you guys are in that phase right now. But I spent most of my time just really trying to immerse myself in just the classes that I was taking, some of the side research that I was doing, and honestly, just trying to get to know my cohort and people around me, and just hoping something would sort of naturally over time just to naturally come to me with what I should do a thesis on. And it was my second quarter of grad school that I considered the idea of applying for internships over the summer to try and take advantage of the opportunity to do something brand new, which was definitely a high priority for me. And that ended up being one of I'd say the best decisions I made during grad school. So I had applied for this internship at the CAISO, and got a position on the policy team that summer. And for that summer, I had the chance to learn a whole lot about the, electricity market and resource adequacy and resource procurement. And to be honest, I actually didn't know much about the CAISO or the electricity market when I started there at the beginning of the summer. But that just ended up being such a valuable experience to open up so many more new doors for me. That was definitely a very eye-opening experience. And so I really tried to take what I learned from that experience at CAISO and tried to figure out how to combine or mold at least some part of what I had learned at CAISO with the land use mapping skills that I had developed and some of the motivation behind the research that I was doing with Rebecca to develop my thesis. And I ended up doing some really interesting work looking at California energy providers and comparing their energy portfolios to try to understand really how local and renewable different types of energy providers' procurement choices are. And that was a really fun project. And that research it got me a lot more interested in wanting to work either for a CCA or a utility after graduating school. And so I ended up applying for both. In addition to, there were a couple other jobs that I applied to, and it came down to choosing between Peninsula Clean Energy, which is a CCA in the Bay Area, as well as PG&E. And I did decide to join the big utility, and I have to admit it was a really tough choice to make, and there were a lot of pros and cons to both of them. But I was mostly just excited for the PG&E position because I saw the opportunity to be able to work across a lot of different groups throughout the company, and I just saw that as a really great growing opportunity and being able to get a lot of exposure. And so I did decide to work for PG&E, and so far it's been a really good experience. I joined the microgrid strategy and innovation team, and I've worked so far on a few different initiatives and programs. But just to highlight just kind of one piece of the work that I'm doing most recently is I've been working on designing this program that the CPUC has mandated that the IOUs jointly develop together. And the CPUC has allocated $200 million towards this microgrid incentive program. And just the intention of the program is to support these customer-driven microgrid projects that serve critical facilities as well as disadvantaged and vulnerable communities. And so that has been a very rewarding process, putting that program together. And actually, we filed that implementation plan for this microgrid incentive program. It'll be filed by the end of today, which was a lot of work over the last few months. So today marks a pretty big milestone for the work that I'm doing at PG&E. And happy to talk about some of the other work that I've done at PG&E as well, but I thought you at least have an idea of the things that I've been up to over the last maybe 10 or so years. And feel free to ask any questions about any piece of that. So thank you.
Thanks so much, Madison. I'll invite again anybody who has like a quick detailed question to raise their hand if you have any. All right, well, thanks for joining us, Madison, on the day that it's due. I'm sure that if you're anything like most faculty, there's a lot to do on the last day. But in any case, I'd like to pass the virtual microphone to John. Please go ahead.
Thanks, Alyssa. I will echo both Madison and Armando's thanks for inviting me back to participate in this. And it's really awesome to see how EGG has come into being, and not only that, but has grown and to have this many students on the call and to be producing graduates like Madison and Armando who are doing amazing work at their institutions. This is it's awesome to see. So I'm happy to be back, and I've got a little bit longer history after my Davis career. So I'll try to give you a brief summary of my tour around the country, I suppose, since then. So I did my PhD at Davis in the Ag and Resource Economics department. And I finished in 2013. So I was on campus from about 2009 to 2013. I worked at the Energy Efficiency Center I got to work with Ben, and I worked with Siva Gunda, if anyone knows Siva, who's now at the Energy Commission, and worked as basically a student researcher for a couple of years. I was really interested coming into grad school in energy topics and development, actually. Those were the two areas that I wanted to pursue research in. And throughout my time at Davis, I gradually just shifted more to energy. And by about halfway through, I decided, all right, energy is where I want to be. How many different energy things can I get involved in on campus to supplement my PhD training? And so I found out at the Energy Efficiency Center, and this seemed like a really great opportunity, particularly because I also sort of figured out about halfway through that an academic career path was not something that was going to necessarily be for me. And so I really wanted to be out in the industry or out on sort of the front lines of applied research. So to tie into Armando's specialization a little bit, one of the projects I remember working on was with Microsoft, and they had an automated fault detection pilot that they had run with their campus up in Redmond. And so we wrote a little paper about that and presented at the conference down in Monterey, which was super neat. And I got to do some other work with SMUD and Chevron and some of the other supporters of what is now EGG. So like I said, I finished in 2013. My first job out of Davis was at a small consulting shop in San Francisco called Freeman Sullivan and Company. And FSC specialized in program evaluation and pilot design for time varying pricing programs and demand response, and some of the, at the time, more emerging technologies like smart thermostats and electric vehicles. So our clients were utilities. We worked with PG&E a bunch. They were probably our biggest client. We also worked with the other IOUs in the state, as well as a few other utilities around the country like Duke and Con Ed in New York City. So our primary role was, we were really specialists in estimating what the load impacts of different DR programs or different technologies or different pricing structures were. How many megawatts do those things, how many megawatts of reduction are you going to get from those things? And how does your program design affect how many megawatts you're going to get? So we used a lot of experimental methods. We ran a lot of randomized trials and quasi-experimental methods, everything from fully experimental all the way down to full-blown regression models where you're trying to piece together a counterfactual based on whatever you've got available. So that was a really great first job to get hands-on with a lot of cool methods and a lot of interesting data. When you work with utilities, there's a ton of really great data that's available that nobody else really has. And so there's some really neat opportunities to use that to answer some interesting questions. So I was at FSC for about a year when my wife, my now wife, was also a Davis student. And so she finished her PhD a year after me. And so she went on the job market, and it quickly became apparent that the Bay Area was probably not going to be a destination for where she was going to end up. So we looked around, and what I've learned is a common outcome is that it turns out that dual career couples tend to funnel to Washington, DC. because there are so many jobs available in DC, or at least a lot of research jobs available in DC. So that's where we ended up for our next stop. And I stuck with the consulting firm for a little while longer. They ended up getting acquired by a bigger consulting firm, which happens in the consulting world somewhat regularly. So the new firm was called Nexent. Also works with a lot of California utilities and has a big California presence. So they had a DC office, and so I worked there for a little while longer, but then made the move to FERC. So the Federal Energy Regulatory Commission, which oversees the wholesale electricity and gas markets all across the country. So the ISOs and RTOs, their regulator is FERC. So I joined a group in the Office of Energy Policy and Innovation that really specialized in empirical research to support the casework that comes through the commission, as well as the new policy development that they're working on. So FERC had recently gotten access to basically all of the market data from all of the ISOs around the country. Super granular 5 and 15-minute data on energy offers from generators and load and all of the resource characteristics, all of the market clearing outcomes, prices, you name it. If it's happening in the markets, we had access to that data, which was, again, pretty cool. As somebody who was really interested in empirical work, having access to that data and being able to connect it directly to policy, which is what FERC does, was really neat. So I was at FERC for about 3.5 years. And then we decided, my wife got an offer at Arizona State University. So we made the move out to the desert. And I moved on from FERC to my current place, SRP. So SRP is Salt River Project. We're a public power utility here in the Phoenix metro area. So our headquarters are in Tempe, which is one of the cities, that's where Arizona State is, and it's basically Phoenix. So our service territory is the Phoenix metro area. We are both a power and water utility. So we provide water, about half of Phoenix's water supply through a watershed that is not coming off the Colorado. So there's a separate water system northeast of Phoenix, the Salt River and the Verde River. And so we manage that watershed and run that water through canals to bring it to Phoenix. But we also supply power to about 1 million customers in the Phoenix metro area. So my first role at SRP was in the strategic planning group, which is not too far off from, I think, Madison's group or the type of work that goes on. So that was a great introduction to sort of everything going on across the utility at a high level. And, you know, Phoenix is a new place for me. There are some unique things about the desert from an electricity perspective that I needed to learn about. And so strategic planning was a great way to learn about what the pressing issues are and just sort of how SRP works. So I was in strategic planning for about a year and then took a new role in my current position, which is in the resource analysis and planning group. So a bit more technical. We do all of the production cost modeling for the utilities. So we sort of own the long run 30-year planning model that simulates how the system is going to run and can study what the consequences of adding different resources are to the system. And so in addition to that, and one area that I've been focusing on a lot has been resource adequacy. So we do also all of the probabilistic studies about loss of load and resource margins to figure out, how many resources do we need to add? What types of resources do we need to add? how much capacity credit should solar get, how much capacity credit should storage get, and all of those emerging issues. So I've been in that group since April, so still relatively new, only about 6 months. But it's been great so far, and that space is really exploding right now, I think, in terms of the types of issues to study and to analyze, and not just at SRP, but everywhere in the West. Resource adequacy is a humongous issue right now, and there are a lot of regional type studies that we've gotten involved in to think about new ways to address that. Historically and traditionally, every utility has kind of tackled resource adequacy on its own, at least those utilities that are not part of an organized market. And now you're starting to see things like the Northwest Power Pool is starting up a regional resource adequacy program. We've done some work with fellow utilities in the Southwest to look at resource adequacy on more of a regional Southwest, desert Southwest basis. And so there's some interesting and exciting things going on there, and the momentum for market expansion in the West has really picked back up. And you can see it in CAISO with the EDAM developments, and you can also see it, SPP is expanding their market products, and there's just a lot. The discussion around what is the future of wholesale markets going to look like in the West is a really front burner issue for a lot of utilities right now. So we're certainly participating in that discussion and thinking about it hard. So I'll stop there, and thanks again. I'm looking forward to questions and more discussion.
Well, thanks so much to you, John, as well. So guys, this is your opportunity to ask questions. I mean, I'm intimidated by everything that our alumni are doing and have done, but I hope all of you guys are, they've all come here to answer your questions and to give you insights. So please go ahead, raise your hands, and then I'll just call on people as you go. Jess, please go ahead.
Thanks. Sorry, I go on walks during these seminars, so I'm currently outside. That's why the video is like this. Thank you all for the great information. I actually have a question for Armando. As somebody working at a national lab, I wanted to know more about kind of the flexibility of your projects, and how much like, I guess, opportunity you have to pursue your own interests, and also like sway in kind of deciding what research projects you are doing. Just because I'm interested in working in a national lab as well, and kind of wondering about those aspects. Thanks.
Yeah, thanks, Jessica. Man, it's a beautiful day out there in Davis. It's really foggy here in the Bay Area. Anyway, but yeah, that's a great question. I think I would say there's no shortage of work at all, at least for me. My mentor Marco Bertoni, I'm actually in his office right now, he's always told me to like basically always say yes to things, opportunities that come across that can lead to some detrimental results for sure. You got to draw your boundaries. But what I'm trying to say is I do think national labs have a lot of flexibility for the projects that that you'd like to work on, and I think that's something that you need to make sure that when you look at job posting for a national lab, or you're in contact with someone who might want to hire you, that you make your interests known right off the bat. That's something that my supervisor did a good job of saying, okay, well, here are the projects that I have funding for, and this is what the projects are. Do any of them interest you? And I got to kind of have my pick of the couple projects that they had, right? And like that's something that you almost have to advocate for yourself in that way, and make sure that you're working on stuff that you want to work on. And I think the focus more recently nowadays in Department of Energy and the funding that provided for National Labs has been more deployment focused. So kind of, I'd encourage you to see how your interests kind of lie in that field, and I think you'd have no shortage of opportunities there. And at a national lab, I definitely would recommend it. It's really good work, really stimulating, mentally stimulating, pretty difficult at times, but very rewarding at the same time. So yeah.
Thanks. That was a lot of help.
Problem.
Daniel, please go ahead.
Hi. I just wanted to say thanks to everybody for coming. I really appreciate these, especially it's great to have that like closer connection to the one step further. I'm in my second year of my master's, and so I'm already like facing forward to where you guys are, and it's really nice to be able to talk to you. I specifically got a question for John. You were talking about sort of using regional resource adequacy strategies and sort of extending where you can, balancing, grid balancing. And I know that that's, people are talking about that, but people have been talking for quite a while about making microgrids as a way of establishing resiliency. And I was wondering if you feel like those two strategies are at odds with each other, or if sort of looking at the bigger regional way, I don't know, they almost seem like they're opposed to each other, but maybe they're completely not. I don't know. I would like your take on that.
That's an interesting thought, Daniel. My initial thought is that they're not necessarily at odds with each other. I think they're coming at a similar issue from two different places, right? So everything that's going on with the regional resource adequacy programs and sort of that level is from the wholesale side, right? It is transmission grid level. That's what's driving it. Whereas microgrids are the complete opposite, right? Microgrids are being built from the distribution system up and connecting to the transmission system. So I think resilience is something that traditional resource adequacy constructs have struggled with, both from just defining what it is to, even if you can agree on what it is, how do you incorporate those sorts of things into something like a capacity market or something like a bilateral construct where you're trying to meet a determined reserve margin. This is a great example of where your traditional process and utility structure is maybe not super well suited for these emerging issues and where things are going. I haven't thought about microgrids a lot, and Madison's probably thought about them a lot more, so she may have some interesting insights here as well. In theory, I don't think it's impossible to bring a microgrid into a resource adequacy construct. I'm not sure exactly what that would look like, but I don't think it's fundamentally opposed, to get back to your question.
Thank you. I don't know, Madison, do you have any?
There's a proceeding going on around this issue, and I haven't been as close. I need to read up on emails that I've been on behind because I wasn't involved with providing comments for that. So I have to learn a little bit more about that. But from PG&E's perspective, that's why it was really nice to hear John's perspective. But we do see them kind of as opposing. You island these microgrids that otherwise these resources could be supporting the broader grid, and having them pull out and just supply a smaller load is definitely problematic from PG&E's perspective. And I think there is some confusion with, how microgrids can contribute to that. I have a lot more to learn in that area, but I kind of come from your perspective as they don't seem to be supporting kind of one another. I don't think microgrids are a solution for supporting kind of the broader grid in that way. But I'll go read up more, and I can follow up with you. We did file comments on that if you wanted to look, at least from an IOU perspective or PG&E's perspective on that. It's a good question.
Thank you.
Okay, well, this is for you guys, but in the absence of students raising their hands, I'm gonna ask questions. Oh, good. There you go, Tanner.
Come on now, it'd be weird if I didn't talk for once. This is kind of towards Madison and I guess John too. Kind of just speak to your path towards like going for your PhD. And I know Madison, you said you weighed both and kind of went industry. Just kind of what your own personal journeys are to that and kind of why you chose that route. And then John, obviously you staying in or going back to the industry versus staying in academia, just kind of your personal journeys related to that.
Sure, I can go first and speak more to the academic versus non-academic track. I think my real passion and focus related to energy was sort of data intensive and empirical research, and then policy relevance. And I certainly don't want to imply that you can't do those things in an academic setting, but in my mind, I saw a lot of opportunities to do those two things outside of academia, and just to be maybe one step closer to the policymakers, the decision makers, or the kind of the front line of where the individual decisions are being made about whether it's investments or different policies within a utility that has a service territory. So that was kind of my mindset, is like, I want to be as close as I possibly can to where those decisions and the information going in to inform those decisions is being made.
Yeah, I definitely agree with you, John, on that. And I'd say part of the reason I did go back to grad school or go to grad school was, I was in a very research heavy sort of doing research, and I was looking for kind of a new opportunity and being able to pivot to something a little different. And that's where my experience at CAISO and just having an internship and testing out something different was really helpful during grad school. That made it a little more clear that I wanted to go in another direction, and there's always the opportunity to go back towards research again. But I think, at least for me, that just these experiences that I've had have kind of solidified that for me, that it's just a better fit for who I am and sort of what my interests are. But I was dabbling in both. Do I stay for a PhD? Do I kind of stop at a master's and kind of continue on? And at least for me, I'm happy that I know enough PhD students, and it was clear for me that master's was perfect for what I want to do.
And one more thing I'll add is that I think there is a trend in academia where you're starting to see more and stronger partnerships with institutions outside academia. So I know SRP has a very robust relationship with Arizona State, and we've got a whole research portfolio of projects that involve academics who are in various departments, whether it's engineering or the business school or the School of Sustainability. And I think that's becoming more common, especially for academics who are interested in doing applied work.
Thank you.
Jean, please go ahead.
Thank you, Alyssa, and thank you all for speaking to us today. It's really good to see you, Armando and Madison, and nice to meet you, John. My question is more towards John in terms of your background in the ARE program. So as I understand, I'm doing my master's in the ARE program right now. It's a very rigorous academic program. And after you finish your PhD and now going into industry, your priority was working on applied issues, but how do you balance like the rigor that you get from academic training with the industry, the demand in industry, because it's definitely challenging to try to explain some of these economic concepts in the industry. So I just wonder how you juggle that in your job. Thanks.
Yeah, good question, Jean. And I think one thing I noticed when I was going through my PhD training and my PhD courses, and going through all of that rigor that you're talking about, and all of the theory and all of the just, the advanced, all of that training. To me, at least, it seemed like there was this tremendous gap between what you learn in your graduate work and then what is maybe happening out in the industry, or what's actually going on. And so to me, there was this opportunity to either bring a little bit more rigor to some of the things that were happening, or to use the training to innovate on the methods that currently existed in the industry, to try to help move some things forward, especially on emerging issues. And I think going back the other way, the thing that industry really helps you with is, when you're out in the industry, you need to convince somebody that it's a good idea to do it a different way, right? So you have this sort of natural test for, is my idea useful? If you can't convince anyone at a utility or a policy, a legislature or a group that's making decisions about this, like if they are not naturally bought into your idea, then you either need to rethink the way that you're presenting it, or come at it from a different angle. So I think that's a nice aspect of working in the industry, is that I don't often worry about, is what I'm doing useful? Like it's almost always useful by nature of the fact that somebody is letting me work on it.
Right, Mina, please go ahead.
Hi, yeah, I also wanted to echo what others were saying about, thank you so much for talking about your experiences. Like, it's always really helpful to hear. And then I had a question specifically for Madison mostly. So when you were talking about developing the microgrid incentive program, I was just wondering your thoughts in general about what it's like to work on developing an incentive program, and what were some of the things that you found exciting, and also maybe unexpected challenges that came up?
Thank you for the question. Yeah, I've found developing these programs. There's two programs that I've been involved with: the Community Microgrid Enablement Program and then the Microgrid Incentive Program. And both of them have been really, as at least kind of new at someone at PG&E. I've been around for 2 years, but these are pretty big programs that involve kind of working across a lot of groups throughout the company. We work with the electric ops team to make sure, we're kind of including them, because this will impact them in the long run when we actually have microgrids that are developed on our grid. We work, a lot with our legal team. Anyways, I did talk about sort of, I wanted to be in a position that would expose me to a lot of different groups and get to know kind of different perspectives and people. And this developing a program will do exactly that. You work with the finance team, you work with the CPUC on things, you have to update them and inform them of why you've made certain decisions within the development of, or kind of that implementation plan that you've filed. You work with stakeholders. That's pretty intense, working with customers and CCAs, and it's been a really exciting experience. A lot of times it does feel there's moments when you develop these plans or these programs, and there's definitely moments where it's a little overwhelming, where you have these deadlines and you have to have everyone's input and addressing their comments and stuff, and that can be a very intense process. So there's moments where it is definitely an overwhelming experience, but it's very satisfying to have days like this where we're filing something. Who knows what the reply comments will be like, but there's something that's actually out there that there will be microgrids on the grid, and we're supporting those. Hopefully we're going to be funding projects that are in definitely disadvantaged and vulnerable communities, and supporting critical facilities. That's our hope. we put a lot of thought into how to design this program, and you just hope that that the result is what you're intending to do, which is challenging. So I don't know if there's any other specific question in there that you'd like to hear about, but it's my experience so far.
No, that's great. Thank you.
Well, can I kind of ask two things? The first is from Madison and Armando, because you're in the actual egg program. I know from hearing from a lot of our new students, as they choose classes, like, can you pick one or two classes that you think in your professional life have sort of been the most useful from the egg curriculum? Or from the, not our specific egg classes, but all of the electives and stuff as well.
I can quickly go. It's okay, Madison. I was actually trying to pull up I was trying to log into my Canvas account before this because I wanted to remind myself what classes I took, but I guess our accounts are not existent anymore. I don't know. Anyway, so I'm gonna try and like think about all the classes. The first class that pops up, and I'm sure this is said over and over again, and it's because it's true. I don't know if it still exists, maybe virtually. I don't know how it works virtually, but the Sustainable Industry Immersion class that Ben teaches, yeah, that was a class that was really interesting, and I still carry that experience with me to today. Basically, if for y'all who don't know what that is, it's basically just a class. I think it's winter quarter, where we invite people from industry, usually, I don't know, energy focused people, and they bring up a sort of case study or a problem. You get some information probably earlier in the week, and then you show up on Monday. When I had it, it was at the Graduate School of Management, really fancy boardroom. Anyway, you like show up really dressed up, and you basically have to pitch the solution to these people with the slide deck that you have like about an hour to prepare. So it's like very like fast lightning round type of pitching, and it really helps refine your presentation skills. And I think mainly what it allowed me to do is become a little more confident, and I guess the ideas I have, I guess, right? Because you don't have time to doubt yourself when all you have is an hour to put something on a slide deck, right? So you really have to kind of you run with the idea that you have, run with the solutions that you might have, put it down on a slide deck, support your idea. I've had to make slide decks last minute for work nowadays, and that experience of like putting together a slide deck real quick really did help too. Like, I don't know, it's just kind of a neat one, I'd say. I mean, in terms of other classes that I took, maybe one more. I took an HVAC class with my professor. That's one of the sort of like elective classes. So that was really beneficial for me. One, to become more closer to my PI, but also to refine the skills that that I'm trying to develop for my career, right? So that was a pretty big one for me as well. So yeah, so I'll let someone else go, or Madison.
Yeah, so I'm also going to suggest that Energy Immersion class too. I actually didn't take it, but I got to sit in on one of the classes and just was in awe at what the egg students could do in the very short amount of time that they had. And I would say, at least for the career path that I've chosen and where I'm working, the skills that you develop in those classes and that you practice are very practical. You're using them constantly in at least the policy kind of world. You have to think quick on your feet. You have to, create a slide deck, or you have to be innovative, right? That's the first thing, is just kind of being able to develop these ideas in a pitch, and then you build that deck, and then be able to present these, your presentation. It's almost improv, and that's really helpful skill to develop. The other class that I did take and that I very much enjoyed was Dr. Bushnell and Dr. Sperling's class, which I'm sure is still being taught together with the two of them. I think energy.
Climate policy or
Yeah, I'm sorry, that class is no longer being taught.
Okay.
Yeah.
Well, that was just, I guess, one of the reasons I really liked that class is it was live debates kind of. I felt like in that class between Dr. Bushnell and Dr. Sperling, who had two very different perspectives on things, and it was really just helpful to kind of listen in and hear and watch them talk about a lot of things. And the policy briefs in that class were really helpful and something that definitely, I have to write up a lot of things, and the policy briefs, you have to write from kind of a different perspective, from kind of an economic standpoint, and being able to develop that skill for me was really helpful. I had done just a lot of research papers and that sort of thing, and so it was good practice. So I'm sure there's other classes that develop those sorts of skills as well, but those are two. And I did love, Alyssa Kendall, your class, the life cycle analysis class, which I sure hope is still being taught.
I'm still on the hook for that one. Yeah.
Okay,
Yeah,
good.
it better be taught. Yeah.
Yeah, I'd say that one, it really sticks with me because it's just everyday thinking about things when you compare different things and kind of thinking of things holistically. That was a kind of a life impactful sort of class that was really enjoyable. So those are some of the ones I'd highlight.
That's really awesome to hear. Thanks. I'm gonna. There have been a few comments that came in on the chat. One also to point out. Ben pointed out that he teaches that immersion class every winter. So even if you can't take it this year, you can take it next year. And then one comment. Let's see. Yeah, is there anything that you wish you had done in grad school that you didn't do now that you're out?
That immersions class. No, I guess, it would be helpful to have more of an engineering background, I guess, even in my role. The microgrids that we're working on, these little projects, they're very technical, they're very complicated. And if I had a deeper understanding of really how they work, I think it'd be easier to communicate things and really have an understanding of why things are so complicated. The people that are able to describe those things to policy people are the people I really look up to. They come from these engineering backgrounds, so they're able to talk about it. And if you have that skill to talk about it at kind of a higher level, it's so helpful. And so I wish I had maybe taken at least one kind of or two more engineering based classes to support with that. I think that would have been definitely helpful. Yeah.
Great, thanks. John, I see you're unmuted.
Oh, I was just gonna say, I wish I would have started like 3 years later so that I would have gotten to take advantage of egg or whenever egg started. And also I think, speaking of Jim Bushnell, he came to Davis right at the tail end of my stint there. And he's somebody, given my career path, I think I would have really enjoyed working with him. So I'm kind of saying this in jest starting later, but the opportunities that you all have to take advantage of with egg and just across campus are outstanding. So just my advice would be, know what your sort of area of specialization is going to be. Like know what it is that you are going to know inside and out, whether it's engineering or whether it's economics or whether it's whatever that is. Know what that is, and then supplement it with as much of the other stuff as you can to learn the institutions and to be ready for the interdisciplinary discussions. Because one thing that is unavoidable in energy related issues is that it's going to be interdisciplinary. It just touches too many different pieces of society and thinking to not be.
Excellent advice. There is one, I see one more question in the chat that's a bit more specific. So this is a question for Armando. And I think this refers back to some of the work that you're doing at LBNL. How does demand response or price signal that you were talking, I think there's just a typo, with respect to LBNL working on is different than Ohm Connect. Please explain a little bit about demand response projects at LBNL if possible.
Yeah, so I'd say Ohm Connect, first of all, is more of like a residential program. For those who don't know, basically you get this text message or some sort of email the day before. Hopefully the day before. It's kind of stinks when it's the day of. You get a message saying from 7 to 8 there's an ohm hour. Please reduce your load, and it incentivizes you with money or points, and disincentivize it if some sort of baseline is created, and if you use more you lose points. And it's more of an event-based demand side management like strategy. So given a certain a projection of that next day of high stress on the grid, they Ohm Connect is sort of an aggregator that sort of bids into the market with a certain capacity with all these loads, and they say we want to reduce our collective load by such and such kilowatt hours and megawatt hours, and that's how they sort of have their program. A more price responsive program would look at dynamically shedding and shifting load based on a certain price. So the way I would see it is that's more of like a continuous form of demand side management that isn't necessarily predicated on a high stress day, but just the ever-changing dynamics of a renewable energy grid that we're sort of evolving into. And yeah, I mean, you can use both in conjunction in tandem with each other, but I think they tend to serve different purposes, and at least that's how I tend to see them. Yeah.
Thanks, Armando. I'm just checking through here, see if we have any other questions come up on the chat. Are there any other questions from students? Well, we're nearly at our end time. We usually finish at 11:50. So we've got 5 more minutes. I'd invite our folks here to share any kernels of wisdom, should you have any. And I know Madison already offered to stay in touch. So students, if you guys have any final questions or requests for contact information, please go ahead.
So I want to make sure I echo Madison's offer. I'm happy to. I love doing stuff like this and connecting with students and talking about energy stuff. So feel free to reach out and connect. It would be great to interact with you. In terms of any sort of wisdom or advice, I will go back to, I think Madison was talking about, actually Armando sort of mentioned it too, the thinking on your feet skills. When it does come time to go on the job market and to find yourself a job, I think it is well worth it to dedicate some investment to building some of those skills, because you never know when opportunities are going to present themselves. And the one fun little story that I will share is that the Energy Efficiency Center would have board meetings every so often, so however many times per year. And they very graciously invited all of the students to go sit in on those board meetings. And, the board of EEC, and I'm sure of EGG, if there is still, I'm not sure what the structure is now, but these board member folks were pretty high up people. And so it was really interesting to get to kind of rub elbows with them. I had sort of leaked that I was interested in Rocky Mountain Institute as a potential place that I would love to go work after grad school. And of course, Amory Lovins was on the board. And so I think Siva and Ben both probably were conniving about this, but they basically finagled it so that they told Amory. And of course, Amory basically pulls me off to the side during the board meeting and interviews me on the spot, like 5 to 10 minutes for a job at RMI, which is absolutely terrifying, but was a really, really interesting experience. And of course, I didn't get the job, but maybe if I would have invested some more time and some on-the-feet skills and thinking on my feet, I would have. So you never know when you're going to need it.
That is an awesome story. And it's true, we still do have an EEI board. And EGG itself doesn't have a board, but as part of EEI, I think our students participate in some of those events as well. So Madison, go ahead. I see you're unmuted.
Well, I was just going to say those informational interviews, maybe that's a hard way to go about things, is just to show up to this meeting and have an interview, but just even reaching out to people. And I did a lot of informational interviews when I was looking for positions, and a lot of those conversations were, they're good for you to process things and get someone's perspective on just the industry. And that was really valuable when I was looking for jobs, is just having those conversations, and helped me process what I actually ended up wanting kind of to do. So I push for that a lot. And I will also say that the microgrid space is definitely a growing area, and we will have jobs pop up over hopefully the next few months. And so if you do have any interest, just let me know, and I can at least notify you when I'm aware of a position that opens up.
Yeah, I'm gonna make a pitch too for people to come at the lab as well. I'm aware of a big project, CalFlex Hub, which I believe a couple of students, ex-students, are being funded with the next couple quarters or a year or so. That's PI'd by LBNL. I think that sort of experience working in conjunction with the laboratory is really valuable to several teams here at the lab, and I would encourage you to reach out to people, reach out to me, please, about the nature of the job and just working at a laboratory, as Jessica did a little bit ago. And I would love to get you in contact with the right people, the people that are doing the work that you're interested in. So yeah.
And this is just a plug, a great way to connect with everybody. I think all of Madison, Armando, and John are on our Energy Network, which is the LinkedIn group. So it's a great way to message people and just stay in touch and advertise jobs. We also do an energy, and in this year we're combining it with engineering career fair at the end of January. So if you have, I know I think I have PG&E and maybe an LBNL contact, but John, if you have a recruiting contact, I'm happy to send the invitation to them if there's positions you guys want to advertise to UC Davis students. Always good.
Yeah, for sure. Let's I'll connect with you after.
Okay, that sounds great.
Awesome. Well, I just want to say so much, a big thanks to our alumni for coming back and spending time with us, and for being so generous with your time today, but also with connecting with students afterwards. So I think it's time for our virtual applause, which is always less noisy than than a real one. But thanks again, and I hope we can see you guys back here as well sometime soon.